Every survival plan has the exact same weak point. You store food, you rotate stock, you buy seed packets labeled for long-term storage. But seeds still have to be planted every year. Every spring you are back at the garden center, back ordering online, back dependent on a supply chain you were trying to escape. In 2020, grocery store shelves in the United States emptied in 72 hours. Not in a war, in a supply disruption. In 2024, egg prices rose 60% in a single year because one virus moved through centralized industrial flocks. A single container ship blocked in a canal in 2021 disrupted the global food supply for weeks. The system is not stable. It was never designed to be stable. It was designed to generate profit from your dependency. But there is a different architecture, one where you plant once and the ground feeds you indefinitely, where the soil builds itself, where the system makes its own fertilizer directly from the air, where there is no annual dependency, no seed purchase required, and no outside system to trust. It does not require a farm. It does not require acreage. Families in southern India have run versions of it on plots smaller than most American backyards for centuries. A horticulturist in England ran one on half an acre with almost no labor for 40 years. Indigenous peoples across 3 continents ran this exact system before the industrial food chain ever existed. The science behind why it works has been published and confirmed, and you can begin building it this spring. Welcome to Nature's Lost Vault. What we are opening today is not a gardening tutorial. It is a blueprint for food independence that does not require permission, does not require trust in any outside system, and compounds in your favor every single year you leave it alone. The archive opens in 1960 in Shropshire, England. A man named Robert Hart moves to a small holding on Wenlock Edge with a single purpose: to create a stable environment for his brother Lacan, who was born with severe learning disabilities. Hart starts as a conventional smallholder. Annual vegetable beds, livestock, an orchard. Within 2 years he understands that the system is completely unsustainable. The beds demand constant replanting. The animals demand constant feeding. The work is more than 2 men can carry. But Hart has planted one small bed of perennial vegetables and herbs in a corner of the property. He keeps watching it. It produces without being told to. It does not need replanting. The herbs return every spring fuller than the year before. The perennial greens come back without intervention. He stands inside that small patch one morning and notices the air smells different. It smells the way a forest floor smells after rain. He begins to understand why. He has read about the home gardens of Kerala in southern India, where 3.5 million households have been running layered food systems continuously, some for centuries. Researchers measuring a single third of an acre plot in Kerala found 23 coconut palms, 12 cloves, 56 banana plants, 49 pineapples, and 30 pepper vines climbing the trees, plus fodder for a house cow. All of it growing together. None of it requires annual replanting. The canopy structure, the researchers noted, approached that of a tropical rainforest in its density and diversity. Hart sees what is happening. A natural forest divides itself into layers. Tall canopy trees. Smaller understory trees. Shrubs. Herbaceous plants, ground covers, root crops underground, vines climbing through everything. Each layer occupies a different niche. Each one draws light, water, and nutrients from a different depth and in a different season. Nothing competes directly with anything else, and because nothing competes, nothing is wasted. He converts his Shropshire orchard into a 7-layer forest garden stocked entirely with edible species. By the time he dies in March 2000, at the age of 86, Visitors walk through a gate and find themselves inside what looks like a wild forest. A forest that is producing food from every direction. Here is the science behind why it holds. A monoculture field extracts from one depth, one season, one species at a time. Every year, it takes from the exact same layer of soil. Nitrogen depletes. Phosphorus depletes. Potassium depletes. You buy replacements in heavy bags. Left alone, the field fails within a generation. This is not a flaw in the crop. It is a consequence of the architecture. A layered perennial system works on different physics. Different species root at different depths simultaneously. Ground cover barely scratches the topsoil. Comfrey roots extend 10 feet down, mining minerals from deep subsoil that no vegetable crop can ever reach. The canopy tree roots deeper still. It does something no annual crop can do. It pulls nitrogen directly out of the air. The root nodules of the black locust tree harbor bacteria that convert atmospheric nitrogen into plant-available ammonia in the soil. Ecological researchers measuring the leaf litter from black locust documented it returning 86 kilograms of nitrogen per hectare per year to the surrounding soil. That is fertilizer that never needed to be manufactured, transported, purchased, or stored. It literally falls from the tree. Below the surface, something else is building. Perennial root systems develop mycorrhizal networks, the underground fungal threads that connect plants and allow them to share water, carbon, and minerals across distance. An annual field tilled every spring destroys those networks completely. A perennial system left undisturbed builds them over years, and then decades. The older the network, the more efficiently the whole system runs. This is the compounding dynamic that conventional agriculture never captures. The longer it runs, the less work it requires. Look at what each layer produces when stacked with the plants that fill it naturally. The canopy is where it starts. Black locust rises above everything else. It grows faster than almost any hardwood in the temperate world. It flowers early, and the blossoms are among the most productive bee forage in North America. As it grows, it deposits nitrogen across the ground beneath it season after season. When it is coppiced, cut to a stump and allowed to regrow, it returns stronger. The wood it produces is the hardest and most rot-resistant timber grown in the temperate zone. A black locust fence post sunk in 1920 is still standing. The pressure-treated lumber that replaced it needs replacing every 15 years. One level below, in the shrub layer, comfrey grows. A plant we have opened the vault on before. A single established crown produces for 20 years without being replanted. Its roots function as a living mineral pump, drawing potassium, calcium, and phosphorus from depths no garden vegetable can access and concentrating them in its leaves. When a leaf is cut and dropped to the ground, it decomposes into the soil in 48 hours. Alfalfa and clover, the standard green manures, take weeks. British agricultural trials in the 1960s documented comfrey producing 100 tons of free biomass per acre annually. The global fertilizer industry generates $230 billion a year, selling exactly what comfrey produces at no cost. The key word is free. There is nothing to buy, nothing to order, nothing to depend on. In the herbaceous layer beneath the shrubs, good King Henry occupies the understory shade. Medieval monks grew it as the only green vegetable available through the hungry gap of late winter, those desperate weeks between the last of the grain stores and the first of the spring garden. The Roman Emperor Tiberius demanded it as tribute from Germanic tribes. It produces edible shoots in March, like asparagus, followed by leaves from April through October, like spinach. Its iron content exceeds that of spinach. Its calcium content exceeds that of Milk. It grows in shade that would kill most vegetables, and it returns from the same crown for 20 years. You plant it once. At ground level, purslane covers the soil between every other plant. It is a living mulch that suppresses weeds, retains moisture, and produces one of the richest sources of omega-3 fatty acids in the plant kingdom. In 2022, scientists at Yale described its photosynthetic system as a biological impossibility. Two separate mechanisms operating in the same cell simultaneously, one for fast growth in daylight and one for extreme water conservation during drought. They called it a super plant. Most people in the industrialized world spend money on herbicide to kill it, but it grows without being planted, covers bare ground between every other species, and feeds anyone willing to harvest it. Below the soil surface, in the root layer, the sunchoke waits. This is the plant we previously exposed for yielding 64,000 pounds of food per acre without irrigation, producing more than potatoes in cold climates with no added inputs. Once planted, it does not stop. It spreads through underground rhizomes and returns every spring without instruction. When Lewis and Clark were starving in the Dakotas in 1805, Sacagawea found mouse caches full of sunchoke tubers and fed the expedition. The mice understood the system. They had been harvesting it for years. These 5 plants are not a garden plan. They are a demonstration of the principle. Each one fills a niche, the others leave open. Black locust overhead feeds the soil with nitrogen. Comfrey at mid-height mines deep minerals and mulches the ground beneath it. Good King Henry produces greens in shade that would starve most crops. Purslane covers the bare soil between everything else and keeps producing. Sunchoke fills the underground space and returns indefinitely. The total output of this system cannot be compared fairly to any monoculture on a crop-by-crop basis. You are not comparing sunchokes to potatoes or comfrey to spinach. You are measuring what a single piece of ground produces across all its layers, across all 12 months, for decades, against what it costs to maintain. At maturity, the maintenance cost approaches 0. The production does not. This is not theoretical. The oldest examples prove it with numbers that no annual field can match. The Amazon rainforest is not the pristine, untouched wilderness most people imagine. Archaeological records prove that it was shaped by human hands for at least 11,000 years, through deliberate forest gardening and soil building. Indigenous Amazonian peoples created terra preta, Amazonian dark earth, by composting organic matter and adding charcoal to the poor tropical soil across the entire basin. In 2023, an international coalition of researchers partnering directly with the Kwikuro people confirmed that this dark earth was manufactured intentionally. The soil they created 5,000 years ago is still producing today. It still retains the fertility built into it across those generations. The ancient Amazonians put carbon and nutrients into the ground that outlasted their own civilization. They did not build garden beds. They built an ecology. The food system and the forest were the exact same thing. What fed the people also fed the soil. What fed the soil rebuilt the forest. The cycle never needed to be restarted because it never stopped. Martin Crawford brought this same logic to a 2-acre field in Devon, England, in 1994. He began planting it as a layered forest garden. 31 years later, that garden had hosted more than 50,000 visitors, and it provided the basis for peer-reviewed research on carbon storage and soil fertility. When the Land Trust gave notice to end his lease in 2025, 33,000 people signed a petition to stop it. What was planted in one weekend in 1994 had become something that could not simply be rebuilt elsewhere. The system had compounded for 31 years, and what it had become could not be recreated on a shorter timeline. That is the one thing that cannot be purchased or rushed. Time. The system requires time to establish. In the first year, growth is modest. In the second year, momentum builds. By the third year, the mycorrhizal networks are running through the soil. The comfrey is producing full harvests, and the sunchoke patch is expanding. By the fifth year, the canopy is casting real shade, and the ground beneath it has changed in ways that a soil test will confirm. By the 10th year, visitors ask what kind of wild place this is. By the 20th year, the family that planted it is harvesting more food than they need without purchasing anything, without trusting any supply chain, and without asking anyone's permission. Every annual garden resets to zero each spring. It demands the exact same seed purchases, the exact same soil amendments, and the exact same labor investment every single year. A layered perennial system does the absolute opposite. Each year the soil improves. Each year the root networks deepen. Each year the canopy adds another layer of nitrogen to the ground. Each year the system asks for less and produces more. Robert Hart built his on half an acre in Shropshire. The people of Kerala built theirs on plots smaller than American backyards. Indigenous Amazonians built theirs across millions of acres, and the soil they made is still fertile today. The scale does not determine whether the principle works. The principle works at any scale. A corner of a yard is enough to start. A small backyard is enough to run the full system. The food supply chain will keep breaking. Prices will keep rising. The dependency will keep deepening for everyone who relies on it. But the ground beneath your feet does not know any of that. Plant it correctly this spring, and it will still be producing food in 20 years. It will still be producing when the supply chain disruptions that are coming have come and gone. The knowledge has not disappeared. It is growing in every food forest that has been planted, in every comfrey crown that survived a house move, in every sunchoke bed returning without being told to, in every purslane that comes up between the stones because it was not killed. If this vault changed how you look at your own backyard, do not let that knowledge disappear again. Subscribe to Nature's Lost Vault and hit the notification bell. Every like and every share is one more person who stops depending on a system they never should have trusted. The next vault opens soon.